Our objective for today, I can simplify exponential expressions with fractional exponents. Read together. 1, 2, 3. So we're showing the same concept, aren't we? Everyone, what is our concept? Yes, we're showing exponential expressions. However, we're done with the easy stuff, which is exponents that have that are integers. Now we're going to the funner stuff. So the exponents now are going to become what? Fractions. Bam! Let's go. Some of you are like, Mr. Q. I know. So, with that said, you copy the objective at the bottom left of your Cornell notes. We don't need a fair model today. Okay, so you don't need to fill it out because we already know what exponential expressions are, right? Yes. Numerical and variable expressions raised to a power greater than 1. Remember that? So, remember this question, though. Keep it to your, put a little Post-it note inside your noodle. It says, what happens to exponential expressions that has a fractional exponent instead of an integer exponent? Something's going to happen to the expression if it has a fraction instead of an integer, okay, as an exponent. So, same standards we're working on, exponential expressions. We already know what they are. We don't need this. Yes? Steps. You do need to copy the steps. Here we go. Step 1, it says, rewrite as a radical and factor the number completely. Step 2, identify the index of the radical to find the root. Step 3, raise to the power outside the parenthesis. And step 4, simplify. Copy that. I'll give you some time. If you have your colored pens, get those ready, please. So some of the terms that you see here on the steps you've heard before. Some of them are new. Or maybe you've heard them before in other places, such as movies or such. Who's heard of the term radical? Yes? Have you seen the movie like Teenage Mutant Ninja Turtles? Radical, dude. Right? So they've used that term. Well, that's not what it means in this context. We're going to show you what it means. But also index, we've heard that before, but once again, in the context of what we're going to present today is different. So check this out. Writing utensils down, look up to the screen. Let me show you what radical and index mean. Here we go. I'm not going to use any words, so let's see if you can follow along. Okay. So if I was to give you this, bless you, this is something probably new that you are looking at this time. In the past, you've seen this very similar, but it looked like this. Remember that? Okay? And this, what we used to know it as square root. But from now on, since now we're going to have numbers outside of the square root, it's no longer square root. This is known as a what? Radical. So from now on, the symbol is known as a radical. What does this little number outside mean? What's it called? Index, and I'll show you what it means. This number inside has a special name. This one is called the radicand. Copy that, please. Radicand. So this one is the radical. Radical, dude. And this is the index. And the inside is called the radicand. Okay? So going back to what we started our school year with, remember when we did real numbers? Remember that? That I gave you an example, but before that I gave you this one. We know how to find square roots, don't we? So what is the square root of 16, everyone? 4 or negative 4. But for the purpose of this lesson, we're going to stick just with the positive, which is called a prime root. Okay? Therefore, it's 4. How do we come up with that number? We come up with that number, oh, and by the way, this one is called the root. How do we come up with that number? Well, we think about a number times itself. How many times? Once, twice, 2 times, right? A number times itself 2 times, that gives us 16. And we said 4. What is 4 times 4? 16. Okay, so that worked out. Okay? Therefore, look up to the screen. This tells us that a number times itself how many times? 3 times. That gives us this number. Tell your neighbor what that number is. Everyone, the number is 2. And that one is called, once again, what? The root. Okay? So copy that. This is that, and this is the root. Now that we know how to use this, we're going to move on really quick to get to some fractional ones. Yay. Okay? All right. So now another refresher. Let's see. I'm going to take you back to elementary school. Here you go. Think back to when you were in elementary. And then all of a sudden you get to the cafeteria, they give you sloppy joes and and your vegetable. Sorry, are you? You guys don't like sloppy joes? What? Anyways, now that you're traumatized thinking about it, here it goes. When you were in, I think in 4th grade, sloppy joes and all that, your teacher, once you got to class, they're like, okay, kids, today we're going to learn how to do factor trees. And they had a little Christmas tree ready for you guys and stuff like that. But remember that? Something like that, yeah? Right? Okay. Well, before that, I just want to make sure you guys understand what we're talking about in regards to prime numbers and composites. This is to revisit some of the terms. Your teacher said prime numbers are numbers that only have factors of 1 and themselves. So, for example, 2. Writing utensils down, you're just paying attention, Jesse. Thank you. So 2, the factors of 2 are 1 in itself. 1 times 2 is 2. There are no other 2 numbers that give us 2. Next number, 3, is what? 1 times 3. That's a prime. How about 4? No, that one goes over here because it's 1 times 4 and 2 times 2. Once again, the definition for prime numbers is that it has factors of 1 in itself. Let me give you another one. How about 5? Yes, 1 times 5. How about 6? No, it goes over here, so this is 1 times 6, 2 times 3. How about 7? Yes, 1 times 7. How about 8? No, it goes over here. 1 times 8, 2 times 4. How about 9? No, it goes over here. 1 times 9, 3 times 3. How about 10? No, it goes over here. 10, 1 times 10, 2 times 5. How about 11? Yes, 1 times. Now I'll stop right there. But do you get the idea? Prime numbers, 1 in itself. Composite, more factors than 1 in itself. All right. So on the Q column, I want you to write prime factorization. We're going to do a factor tree. Yay. Give me a number. Okay, 18. Copy that. Copy that on the Q side. Okay? So, we're going to do it a little bit different than how you did it in elementary school. From now on, I want you to think about the first 5 prime to 3, 5, 7, 11. And that's the number we're going to start our factor tree with. Here we go. What number, which one of these 5 primes divides into 18? 2, okay, but which other? And we always go with the biggest one, which is 3. So I'm going to start with 3. 3 times what gives us 18? 6. So we circle the 3. We can't do anything else to the 3 because it's what kind of number? Prime number. So our branch stops there. Does this one keep going? Yes. All right. What factors of 16? Which one of these divides evenly? The 2. But the biggest one is the 3. Circle the 3. 3 times what? 2. But 2 is also a prime. Okay? Therefore, 18 can be rewritten by using these primes. 3 times 3 times 2. What is 3 times 3? Times 2? Bam. You remember that now? And then you went to have sloppy joes and all that. All right. Next, how else can we rewrite this? Tell your neighbor, please. Everyone. 3 to the second times 2. That is correct. Okay? Now, some of those skills you're going to need, and your noodle's going to start turning because you need to be doing some computation when we get to some of the radicals. Okay? Any questions on prime factorization? Piece of cake, right? Yes, Mr. Q. All right, good. Where I want to get to is this next part. I want you to write, if you don't have space, turn your paper over. In the back, I want you to write example Q. And this is where I'm going to walk you through the fractional exponents, okay? Here we go. I want you to write x to the 1/2. Underneath that, x to the 1/5. I'm sorry, 1/3. Underneath that, x to the 1/4. Underneath that, x to the 1/5. Underneath that, x to the what? 1/23. Because I put dot, dot, dot. All right. Everybody ready? Here we go. Writing utensils down, look up to the screen. Let me show you how to rewrite all of these, okay? I'm going to start with the one that we've been using previously. You're saying, we have? Yeah, we've been using this one. Let me show you what this becomes. This becomes the radicand of x with the radical and the index, but we don't write it on that one. Have you guys seen that before? Square roots, you haven't seen square roots? Yeah, without an index, right? Well, if that's true for that one, let's see. Okay, let's go with the next one. Talk it over to your neighbor, see what's going on, and see if you can do the last two. Go tell your neighbor what you get for the last two. Okay, copy that, please, and fill in for x to the 1/5 and x to the 1/23. Go. All right, let's see what we got. How about Nate? Who haven't we picked in a while? Leslie. What'd you get for x to the 1/5? I'm sorry? The radical symbol. The inside is x. What is that called? The radicand, okay. The index is 5. Hands if you got that. Okay, good. Pass someone. Nate. Radical. And that's called radicand of x. Index 23. Hands if you got that? Yes? Okay. So now we know how to rewrite anything that has a fractional exponent. Are we there? Let's try it with numbers. Here we go. Let's do this one together. 9 to the 1/2. Okay, I want you to look at the one I gave you. X to the 1/2 became this. And by the way, this is not a 0. I'm just indicating that there's no number there because we assume that it's a number times itself. So it's a 2, right? Okay. Tell your neighbor, how would you rewrite this? How would you rewrite that? Christopher, how would you rewrite that? What is it? No. I said rewrite it without the first fraction. Radical. 9 as a radicand. Do we write the 2 as an index? No. Hands if you got that. Okay. What is square root of 9, everyone? 3. There it is. And tell your neighbor the name of the 3. What is the name of the 3? The root. Bam. Let's do another one. Here we go. Let's do 8 to the 1/3. Focus, please. Okay, Melanie, tell me how to rewrite this. 8 as the radicand. Three is the index, which means we need a radical, right? We need a radical. And 3 as the index. Hands if you got that. Okay? So what does this mean? It means what number times itself 3 times gives us 8? Everyone, what is that number? 2. And what is that called? The root. Okay, so far so good? Okay, let's do another one. Let's do 16 to the 1/4. Maria, how can I rewrite this? Radicand is 16. Put the radical. Index of 4. And what is the 4th root of 16? Everyone? 2, because it's saying what number times itself 4 times give us 16. 1 times 1 times 1 times 1? No. 2 times 2 times 2 times 2? Yes. That's our root. We got this? Yes? All right. Let's kick it up a notch. Yes? Example, super cute. Square root of 100. Everyone. 10. Example, mega cube. Cube root of 64. Share with your neighbors, see what they got. Mia, what'd you get? Cube root of 64? 4. Hands if you got that. That is correct. What number times itself 3 times? That's what it says here. 3 times gives us 64. 1 times 1 times 1? No. 2 times 2 times 2? No. 3 times. Man, it sounds like a song. Is this fairly simple? Yes? Yes. Let's kick it up a notch. Yes? Example, Shazam cube. Let's see. How about 36 to the 1/2 plus 27 to the 1/3. You're saying, wait a minute. Do you guys know how to do this one? No. This one. How about this one? And then what do you do at the end? Okay. Go for it. See what you get. Copy that. Go. Part. How do we write 36 to the 1/2? What do I do? Radicand is 36. Index is 2, but do we write the index of 2? No. So I just need a radical, right? Okay, so what is this? One number times itself gives us 36. Got it? 6. That is correct. Hands if you got that. Okay. How about Mia? How do we rewrite this one? 27 to the 1/3. 27 is the radicand. Radical. Index of 3. So what is cube root of 27? 3. Hands if you got that. That is correct. What number times itself 3 times gives 27. And at the end, what do? So therefore, this is 9. Hands if you got that. Damn, let's go. One more of these, yes? Okay. Let's do example. Damn, no. Example, Power Rangers cube. Bam. Here we go. Let's do 8 to the 1/3 times 9 to the 1/2. Copy that. See how you do with that. Ready, go. Okay, here we go. This became cube root of 8, is that correct? Which is 2. Times. This is square root of 9, which is 3. What is 2 times 3? 6. Hands if you got that. Okay, good. We got this, yes? All right. Let's kick it up a notch. Now we do example Michael Jordan cube. Bam. Saving the best for the last. Here we go. 27 to the 2/3. You're like, what? Copy that, and then I'm going to go over this example. Okay, writing utensils down. Here we go. The most important one for you to pay attention. Please, if you are to pay attention at this moment. Here we go. First of all, this looks weird, doesn't it? Because we've only been working with exponents that have a numerator of what? 1. So we only know exponents that look something like this. But now what do we have? 2/3. So 1/3 times what gives me 2/3? Tell your neighbor. 1/3 times what gives us 2/3? Everyone times 2. Which means you're telling me that 2/3 can be rewritten as 1/3 times 2. Is that correct? So guess what? That's going to be our first step. I rewrite this. Stop writing. Just pay attention. 27 to the 1/3 times 2. Does that make sense so far? I mean, do you understand this? Okay, so question. Do we know what this is? Yes. What do I write? Index of 3, radical, and what else? 27. Now, question. What's another way of writing multiplication? Parenthesis. And you bring down the exponent of 2. Question. What is cube root of 27? 3. Bring down the exponent of 2. What is 3 to the second? Copy that, please. Bam! I'm telling you, we got this. And for those of you that finished, I want you to do this one by yourself. Example, Star Wars Q. Let's do 8 to the 2/3. Rewrite it, just like we did the other, and simplify it. Go. Hands if you got Star Wars Q already. Okay, tell your neighbor what you got, please. Hands if you got 4. That is correct, because you rewrite this as 8 to the 1/3 times 2, cube root of 8 to the second power. This is 2 to the second power, which is 4. Home plate for tonight. Page 35, all, only page 35. Have a good one, guys. There is tutoring today. If I don't see you, enjoy your home plate. See you guys tomorrow. Bye.